The universe is the entirety of everything that exists, encompassing space, time, energy, matter, galaxies, stars, planets, and all other forms of cosmic structures. It is the vast expanse in which all known and unknown entities interact and exist. As for the origin of the universe, one widely accepted scientific model is the Big Bang Theory. The Big Bang Theory proposes that the universe originated from an extremely hot and dense state. Around 13.8 billion years ago, the universe is thought to have been in a state of singularity, a point of infinite density and temperature. The Big Bang event occurred when the singularity began to rapidly expand, initiating the expansion of space and the decrease in temperature. As the universe expanded and cooled, energy and matter formed, leading to the creation of galaxies, stars, planets, and everything we observe today. While the Big Bang Theory is widely accepted, it doesn't address all aspects of the universe's origin and evolution. Ongoing research and exploration continue to refine our understanding of the universe's birth and development. New models and theories may emerge as scientists seek a comprehensive explanation for the complexities observed in the cosmos. We learn about the universe and its structure through various means of observation and scientific research. Here are some primary methods by which we understand the universe. Spectroscopic observations. Instruments for spectroscopic observation allow us to analyze the light emitted by celestial objects. Spectral data provides information about the chemical composition, temperature, and motion of objects. Telescopes and observatories. Ground-based telescopes and observatories worldwide provide high-quality images of celestial bodies such as stars, planets, and nebulae. Space telescopes. Instruments like the Hubble Space Telescope, placed in space to avoid Earth's atmospheric interference, deliver sharp images of a broad spectrum of the universe. X-rays and gamma rays. Observing X-ray and gamma-ray radiation helps us see cosmic events that are not visible with the naked eye, such as black holes, supernovae, and high-energy phenomena. Radio telescopes and radio observatories. Observing radio waves aids in studying cosmic phenomena like star clusters and galaxies, utilizing radio waves instead of visible light. Computer simulations and mathematical models. Using computer simulations and mathematical models to simulate and understand the structure and evolution of the universe. Space exploration. Space exploration missions like Apollo, Voyager, and modern missions like Curiosity on Mars provide direct information from planets and other celestial bodies in our solar system. All these methods, combined, provide us with a comprehensive and multidimensional view of the universe and its intricate structure. A stellar explosion, or supernova, is a powerful and significant event in the universe, generating immense energy and influencing the surrounding environment. There are two main types of stellar explosions, nova and supernova. Nova. Novae occur when a binary star system, consisting of a white dwarf and another star, transfers material onto the white dwarf. When this material reaches a critical amount on the white dwarf's surface, it triggers an extremely bright outburst. Although novae can be quite luminous, they typically last only for a few days or weeks. Supernova. Supernovae are more powerful explosions, releasing much more energy than novae. There are two main types of supernovae. Type Ia supernova occurs when a white dwarf in a binary system accumulates too much material from its companion star, leading to overloading and explosion. Type II supernova occurs when a massive star reaches the end of its life cycle. As the nuclear fuel in the star's core depletes, the balance between internal pressure and external gravitational forces causes the star to explode. Consequences of a supernova. After a supernova event, energy and matter from the exploding star are ejected into space. These explosions enrich the universe with the necessary chemical elements for the formation of new stars and planets. Heavier elements beyond iron, such as gold and uranium, are often synthesized during supernova events. These events not only contribute to the chemical enrichment of the universe but also have a profound impact on the structure and development of stellar systems and galaxies. The question of extraterrestrial life is one of the greatest mysteries in science. Currently, there is no concrete evidence of life beyond Earth, but there is also no definitive evidence ruling out the existence of extraterrestrial life. Here are some avenues that science explores in the quest to understand the possibility of extraterrestrial life. Life within the solar system. Space exploration missions, such as Mars rovers and planned missions to the moons of planets within our solar system, aim to search for signs of life. Exoplanets. Observing exoplanets within the habitable zone of other star systems to determine the potential for water and conditions conducive to life. Search for scientific signatures. Listening and observing signals from space to search for messages or signals from intelligent extraterrestrial civilizations. Investigating life in harsh environments. Studying life in extreme environments on Earth, such as in high-temperature, saline, or oil-rich environments, to understand the potential for life in environments beyond Earth. While there is currently no direct evidence of extraterrestrial life, ongoing research and exploration efforts continue. These endeavors help us gain a deeper understanding of the diversity of the universe and may eventually provide answers to one of humanity's most profound questions. A black hole is a physical phenomenon where gravity is so strong that it causes space and time to collapse around it. For many, a black hole is often described as an area in space from which nothing, not even light, can escape. Here's how black holes form and operate. Formation of black holes. Black holes often form when a massive star concludes its life cycle and explodes into a supernova. During this process, the extremely strong gravitational forces compress the matter into a very small space, creating an intense gravitational pull. Event horizon. The event horizon is a theoretical boundary that marks the point where space and time are terminated by the gravity of the black hole. If an object crosses the event horizon, it cannot escape the gravitational pull of the black hole. Space-time singularities. At the center of a black hole, where matter has been compressed, there may be a space-time singularity, a region with extremely high density and infinite gravitational forces. Light absorption zone. Black holes have the ability to absorb light, making them appear invisible in direct observational spectra. This gives the impression that nothing can escape from a black hole. Time and space warping effects. In the vicinity of a black hole, time passes more slowly compared to areas farther away due to the influence of strong gravity. Black holes are not only an intriguing aspect of physics but also play a crucial role in the study and understanding of the universe's structure. Exploring the universe poses numerous challenges, ranging from technological and engineering hurdles to scientific complexities and ethical considerations. Here are some key challenges in the exploration of space. Technological and engineering challenges. Vast distances, stars and planets are extremely far away, demanding superior technology for exploration and communication. Time and energy. Space exploration missions are lengthy and require substantial energy resources. Maintenance and repairs. Maintaining and repairing equipment in the harsh conditions of space is a significant challenge. Human protection. Radiation and health factors. Space radiation and the effects of space conditions without atmospheric protection necessitate safety measures for space explorers. Microgravity impact. Prolonged exposure to microgravity can impact the health of individuals spending extended periods in space. Costs and resources. High expenses. Developing and deploying space exploration missions involves substantial investment from nations or international organizations. Limited resources. Resources such as fuel and materials may be limited for long-duration and long-distance space missions. Scientific issues. Understanding the universe. Many mysteries of the universe remain, and complex missions are necessary to answer fundamental questions. Extraterrestrial life. The question of whether extraterrestrial life exists is a significant scientific challenge. Space environmental protection. Space debris. The increasing amount of space debris poses collision risks with exploration objects and satellites. Legal and ethical considerations. Sovereignty and space law. Issues of sovereignty and space law become complex with the growing involvement of nations and organizations in space exploration. These challenges call for global collaboration and technological innovation to efficiently and sustainably understand and explore the universe. The universe is still filled with many mysteries that we have yet to decipher. Here are some of the most significant mysteries and scientific questions that continue to baffle researchers. Dark matter mystery. Dark matter constitutes about 27% of the universe, but its true nature remains unknown. It is a form of non-luminous matter that does not interact with light but exerts gravitational effects. Dark energy enigma. Dark energy comprises approximately 68% of the universe and is the primary driver behind the accelerated expansion of the universe. The characteristics of dark energy remain a major mystery. Higgs boson puzzle. Despite the discovery of the Higgs boson at CERN in 2012, many details about why and how it interacts with other particles remain mysterious. Origin and expansion of the universe. Our understanding of the origin of the universe and why it is expanding at an accelerating rate is still incomplete. Extraterrestrial life. The question of extraterrestrial life is still a mystery. Whether there is life beyond Earth and, if so, how we might find it remains an open question. Black hole information paradox. The black hole information paradox raises questions about information loss when matter falls into a black hole and whether the principle of information conservation is preserved. Cosmic microwave background anisotropy. Irregularities in the cosmic microwave background radiation present a mystery, challenging our models of the formation and evolution of the universe. These mysteries, along with many other aspects of the universe,